Welcome back. Now that we have a positive copper plus 2 ion, we want to model an interesting behavior in the reaction. This reaction of silver nitrate plus copper, when it takes place in real life, actually we see that the solution slowly turns a shade of blue. This blue hue is due to a hydrated copper ion complex. Copper ion with the plus 2 charge forms a stable ion complex with 3 water molecules. So how are we going to model that here? Well, first of all, let's remix our program. And then the one way to do it is to create the copper complex, the copper ion complex with 1 water molecule, then with 2 water molecules, and then with 3 water molecules. So I'm going to go to edit breed, and we see that we have the copper ion agent here. We're going to add a breed and we're going to call it copper 2. We're going to call it copper 2 with 1 water agent, H2O. Then we're going to add another breed, copper 2 with 2 H2O. And the last one and the most stable complex of them all is the copper 2 with 3 H2O. Great. Now if we close this edit breed window and we scroll down, we notice that now we have 3 new tabs. Okay, if we go back to the copper ion tab, we notice that we have a wiggle movement. That's because this ion is actually swimming around in solution. And the same thing is going to happen to the complex with 1H2O, 2H2O, and 3H2O. So we might as well give it a wiggle movement now. The easiest way to do that is to copy this set of instructions or these set of blocks and click copy. Go to the page with the first complex and give it the same wiggle movement. Go to the next tab, give it the same wiggle movement, and go to the copper complex with 3 water agents and also give it a wiggle movement. Great. Now that we gave them wiggle movement, now we have to create them. So where's the copper ions created? Well, they're created when copper collides with silver nitrate. If you remember, if we scroll down here, you will see that the copper ions are created when the second silver nitrate agent collides with the copper. And it's created with a color white, shape sphere, size 1. Remember those? Or better yet, let's copy those traits. We're going to use them very soon. So I'm going to copy them. And now I'm going to go up to the copper 2 ions. In this tab, we are now going to create a collision block. This collision block is in the detection drawer. And this time, the collision is going to be between this copper ion and water. Copper ion and water will collide to form that first complex with 1H2O. So we're going to go to the agents drawer and we're going to get a create block. And we're going to say, when copper ion collides with water, I want you to form 1 copper ion complex. Now when it forms this 1 copper ion complex, it will need some traits, right? What are the traits? Well, it's going to be the same as the copper traits that we had created before and that we copied. And so let's hit paste. And here we are. We've got the same traits as the copper ion. The only difference is I'm going to change the color from white to cyan. And cyan is a very light blue color. Same shape, same size. So when a copper collides with water, it's going to produce this copper 2 with 1 water molecule complex. One thing is missing here still, and that is that you want to delete the first 2 agents that collided with each other. So the copper ion colliding with water now needs to be deleted. Water is the collidee, the copper is the collider, or we can just say delete, and it will delete the copper. The agent that needs to be deleted is the collidee, and we find that in the detection drawer. And here we are. So what did we do here? We collided the copper ion with water, we created a new complex that has cyan, that is cyan in color, and we deleted the water agent and the copper agent, this copper agent, by hitting delete. Let's go and test it. So we changed the code, so we have to click on run code first, and then we're going to click on setup, add copper, and add silver nitrate. And I'm going to zoom in. And don't forget to use the copy and paste feature. It will save you a lot of time.